Last lecture, there was a question I could not answer. One of you asked why this example quantum oracle in Groover's algorithm has y to have 0 as the input, right? But then later, when we try to come up with an exclusive or quantum oracle for the actual implementation, instead of using 0, we use negative. Okay, this is the reason. First, just review. We had came up with a phase oracle, right? And this phase oracle has the effect that you multiply -1 to the power f of x in front of the vector going into this v. And we show that by just going through v and w and you keep repeating, you achieve the operation of rotating the vector by 2 theta every time. And eventually it will reach somewhere very close to A. Right? And that was proof already. You can watch the previous video. And then we try to come up with exclusive or quantum oracle. And also through this proof, we show that it has the same effect as a phase oracle. Right? But we ask you to have y equal to negative in order to get -1 to the power f of x, right? So in summary is that by setting this quantum oracle to have y equal to minus, then it will achieve the function as a phase oracle, which has proved to be working. And more importantly, in this process, the y qubit, which is minus, is not changed, as you can see from here. So it can keep looping, right? Now, then what is the problem of this quantum oracle? So I did not make it clear because this was introduced before we learned the algorithm. This oracle cannot be used directly into that algorithm, right? That is the first thing. If you really do that, you find that it won't work. Second thing is this. We put 0 as the input. And you will see that when it is x equal to a, you will get 1 as the output, right? Because this is 0 exclusive or f of a. Now, what if it is not a, x not equal to a, then your f of x is equal to 0, then your output is 0. So the way this quantum oracle capture the function is that it will give 1 in the y qubit, and then if it is a, and you will give 0 in the x qubit when it is not a. Now then this makes things not as great that you cannot use it for quantum oracle implementation. So what we did here with this negative sign is that, as you have seen in the proof, is that you don't change the y qubit at all, but you only move at the phase to in front of x or the whole system. Okay, so in summary, we need negative as the input to use the algorithm we have developed. And why we use 0 here? It is not the exact oracle we can use, but this is just for illustration purpose. Okay.